Example 5 is the same thing. It says use the function g of x to answer the following questions. So the first thing we need to do is graph our g of x. Now, because this isn't linear, we're just going to go ahead and use our calculator here. So I'm going to write my ordered pairs here for my g of x. I'm going to write down as many that will fit in my standard graph here. So getting your calculator out, we're going to go to our y equals and type in our function. Okay, I'm going to hit zoom 6. So 1, we can see what the graph is supposed to look like. But what I really want is the table right here. So second graph. And here are my values. So that -2, -15 is too big. So we'll start at -1, -1. We have 0, 1, 1, 3. And then 2, 17 is not going to fit. So I can only fit these 3 ordered pairs. So I'm going to graph it, and then keep in mind this is what the shape of this graph should look like. So we've got -1, -1, 0, 1, and 1, 3. So what's going to happen is it's going to kind of curve down and go straight down there and curve up like so. So then part B wants to know, is this a one-to-one function? And again, yes, because anywhere I put a horizontal line, it only intersects once. So yes, because it passes that HLT. So in part C, does my g of x have an inverse? And yes, because it is one-to-one on part B, that means yes, it has an inverse. So if it does have an inverse, graph the inverse on the same plane. So right here beside, I am going to write my ordered pairs for my g of x. And all I'm going to do is take my x column, and that becomes my new y column. And then my y column will become my x column. And now let's plot these ordered pairs. So -1, -1 is on that same point. Then we have 0, or 1, 0, and 3, 1. And so this one is going to kind of snake like that in the opposite direction. So there is my inverse function. And I forgot to label. So let's label this one as g to the -1. And this one is my regular function g. And I'm a visual person, so I like that line of symmetry right here on my graph. I'm going to do a dashed line. This is my y equals x line. So we can see everything is equal distant from that line of symmetry. And then part E wants me to find the inverse of g of x. So we have graphed the inverse. What is the name of this function here? So looking at my steps from that previous page here, the first step is to replace f of x with y. So instead of g of x, I now have y equals 2x cubed plus 1. Step 2 is to interchange our x and y. So now this is x equals 2y cubed plus 1. Step 3 is to solve for our y. So to get y by itself, the first thing I'm going to do is subtract my 1 over. We get x minus 1 equals 2y cubed. To solve for y, I need to get y cubed by itself first. So I'm going to divide everything by 2. This side here can't simplify at all. So that is x minus 1 over 2 equals y cubed. And now what is the opposite of cubing? Cubing y, and that is to take the cubic root. So just like the opposite of squaring is to take the square root, the opposite of y to the third power is to take the cubic root. You always want that exponent and that index to match. So my radical and my cubed cancel here, and I can't do anything with this side again. So this is the cubic root of x minus 1 over 2, and now that equals y. Do not stop there. We have not gone through all 4 steps. Our last step is to replace y with our inverse notation. So because we had g of x, this will now become the inverse of g equals the cubic root of x minus 1 over 2.